either, I said, Israel's first, or I'm going to give my quick talk, then
Yeah,
Israel. This one's set up for here.
Okay.
Could we do that?
Sure.
Are you okay with that? And are you okay with that?
Yeah.
Okay.
You want to sit, Kim? You can sit here and plug in there too, if you want. Yeah. Yeah, you can. You gotta flip that up, but you can plug in there. You want to keep? You want to mess with the camera? Where is the camera thing? I think yeah. Switch the view to. You'll probably have to look on your computer because I haven't. Yeah, while she's doing the intro. All right, thank you everyone for making your way back in here. We've got Ito. Okay. As you make your way back in, to find your seat, it's someone else.
Imam.
All your audio.
I turned right off. But that might have been.
Okay.
I guess that's just not going to work.
I mean, I've got my thing hooked up. So, do you want any other? Whatever. I have these older ones we need to get you on. I know. And I. All right. And you need that, already finished it.
Okay. This is what I really want. Kind of this side, everything goes from our cover sheet, but this one with the country, that way I'll talk about the different locations.
Well, I can just go to this slide.
Okay, go to that one. Let's get one on the GPA summary slide, and everything.
Nope, but I'll add it to the end of it so we can have it at the
I
end.
don't need to. It's time to start.
All
I
right.
can do that, but next time we'll do like that.
I have it on the last.
Yeah.
But
We don't need it. I want to go pretty
yeah.
quick. All right, if everybody here at Assembly Norfolk could take your seat, we're going to get started here in just a few seconds. So everybody take your seat, grab another water or coffee if you need to, and we're starting in about 30 seconds. Thanks. All right, good afternoon, everyone. Are we good with the online connections as well? Good to resume. All right, well, welcome back, and thank you again to 757 CoLab, our amazing PIA partner that provided that very yummy lunch for us. So I had a couple of questions about what's this Tech Bridge thing? So we decided I'd give a real quick spiel on the Tech Bridge in just a few minutes. You can learn more about it. There's QR codes that really smart young people know how to put on things. So the best way to keep up with our events and the stuff we do is generally through LinkedIn, and then we have a YouTube channel where a lot of our events are recorded, which is a really, really great resource. You can connect with the MATB on this QR code, and we have some little placard cards around the room and out by the lunch where you can learn more about. But just a real quick elevator speech. So the Mid-Atlantic Tech Bridge was started in around 2018. We moved in with 757 CoLab when this building opened in June of 2019. The purpose of the Mid-Atlantic Tech Bridge, along with a network of 17 other tech bridges throughout the world, is to be a super connector. It's to help non-traditional partners. And it doesn't mean that we don't work with bigger companies or larger organizations, but then Secretary Hondo Geertz recognized that there was this mismatch between trying to find technology providers and having them go through all the red hoops associated with how the heck do you work with the government. So From that became the Tech Bridges first, and then Naval X, which is our parent organization at the Office of Naval Research. So they fund money and they're program officers, but the Tech Bridges really are kind of the working arm of Naval X. And like I said, we're meant to be a super connector. Each Tech Bridge has both a regional focus. So ours is here, 757 area. So for those of you who don't know what 757 means, that's our area code. Used to be the only one. I think we have 3 now. But so we focus on this area, but it doesn't mean that we don't work with folks in other areas. We do, as does every other Tech Bridge throughout the world. It means that if there's a particular budding innovative partner in this area, we want to know who they are. And but I say this area, it's not even really just the 757. Work with folks all the way to North Carolina, all the way up to DC, and everywhere in between. So, when I say we work as a network, there's 18 Tech Bridges. They have different technical focus areas, much of which overlap quite a bit, but really any good technology that could potentially help any DoD partner is going to be of interest to the Tech Bridges. So if you want to go to the one with the slide, this is kind of impressive. So this slide, which is just a breakout of the US, shows all the Tech Bridges and our partners. It used to be really, really busy because it had all the partners, which could be we don't have industry partners listed on here because there'd just be dots across the entire country, but it's basically where the Tech Bridges are located. And then you can go onto our websites and you can look at our LinkedIn and you can see what the technical focus area is, how you link up with them, or you can reach directly out to the Mid-Atlantic Tech Bridge. So if somebody already asked, oh, I'm out in California, is there one out there? Yes, they're pretty much all over. If you can think about where there are Navy and Marine Corps bases, that's where we are. Most of us are aligned to particular commands. So for example, I'm from NSWC Carderock. My co-director, who is not, there he is, Gerald is from NIWC Atlantic. So our commands have a large presence here in this area. And of course, because we're surrounded by the largest naval base in the world, that ends up being very handy because we have direct access and we're able to get fleet representatives here. Amazing folks like 2 of the science advisors that work for ONR Global that represent major commands in the area. So it ends up being a really handy thing that we're here, and the other Tech Bridges end up leveraging those connections as well. So I think that's all. Did you want me to say anything else? Okay. The boss says I'm done. I have one question. Excellent question. So the question was, what is a CAW site? So the Marine Corps Warfighting Lab about 10 years ago started having Centers for Adaptive Warfighting. And so so the Marine Corps is a division of the United States Navy. So we work very closely, the Navy and the Marine Corps work together. And those centers were put together to come up with design thinking strategies like Scrum and other things to help warfighters be more effective and more efficient within their warfighting capability. And you can Google it, and there's all kinds of information about it. There used to be a CAW site here in Virginia Beach, but unfortunately with some shortages, they're not. But they still have a presence throughout the country. Anybody have any other questions about Tech Bridge? And like I said, you're welcome to, please, if you haven't already done so, we really appreciate it if you link up with us on LinkedIn. You'll then find out about any of our upcoming activities, and you can also search back about activities. So if you're a small business, a lot of our activities have centered on informing small businesses how to work with the government. And those resources, most of them are available either on our LinkedIn or on our YouTube channel. And if you ever can't find something, you can email the Mid-Atlantic Gmail. It's just Mid-Atlantic techbridge@gmail.com, and you can find that on the LinkedIn. Good. Okay, so next up, we have a partner from Israel that's about to give a demonstration, and then we'll move right on to demonstrations in the room.
Hi, everybody. Hope you're hearing me well. So thank you for having me. Thank you for the last minute invitation and the ability to present. I will need today to squeeze about 30 minutes of planned presentation to 15 minutes, the same presentation I did for the British audience before. But before that, I would like, just as a former naval officer, to thank the US Navy for the support in the past 2 weeks. I live by the sea in Israel, and I personally witnessed the intercepting missiles coming out of the US Navy ships during a few nights in the last 2 weeks. And I would like to thank the US Navy and the US for all the support we got in the last 2 weeks. It means a lot to us. So I'm working at Odysite AI as a senior director for programs, for strategic programs in the past 2 years. Odysite is started as a starter company, actually as a company called ScoutCam almost 12 years ago, as a medical company. And we were actually developing miniature cameras for minimal invasive procedures inside the human body. That was our main focus for many years. Until 2016, NASA actually approached to us and asked us to develop a miniature camera because they heard that we have miniature cameras that can withstand the harsh conditions inside the human body, and to perform the development for them because they could not find any other company that can develop such a very small camera. So this camera that you see here in the image is actually a 1.2 millimeter camera that already flew in space twice. It was used in the International Space Station in 2020 as a borescopic camera for refueling hoses inspection of satellites, actually. The transition that we made from ScoutCam to Odysite AI, by the way, I didn't say before, we are a US registered company. Although we are a startup, we were listed in the NASDAQ about 3 to 4 months ago. And the transition from ScoutCam to Odysite started actually with a very sad incident back in 2017, where an Apache helicopter for the Israeli Air Force crashed during a training session. I actually knew in person the officer, the pilot that died in this incident, Major Durizar, because I was working back then at an Israeli defense company, Elbit Systems, together with him. And when they started investigating this crash, of course, after they grounded the fleet, the Israeli Air Force grounded the fleet for almost a month, they found out that the root cause for the crash was actually a loose yaw push-pull rod that was causing this fatal crash. During regular maintenance, this rod is actually located behind fuel tanks in an area that is unreachable in the daily use of the aircraft. And the push-pull rod, when it was inserted back in place during the closure of the aircraft, it was actually not inserted properly. And the regular inspection missed that. And the aircraft went back to the squadron for flying. And while flying, after deterioration over time, this push-pull rod was disconnected. One member of the investigation committee that investigated this incident was Brigadier General Professor Kobi Bortman. Mr. Bortman was at the time already retiring from the Air Force. He was the head of Material Command. And he had a PHM laboratory, or he still has, in the Ben Gurion University in Israel, focusing on PHM. And he was pretty frustrated from the fact that this accident could not be prevented with the regular means that exist today with the regular or traditional PHM systems. And he was trying to find ways to mitigate these kind of risks in different ways. Then he stumbled upon ScoutCam, and he realized that this connection of PHM with vision, with computer vision, might actually work. So the Israeli Air Force made a connection. They turned to us and they asked us actually to develop a camera that can be used with this Apache helicopter to put in this area and actually inspect this push-pull rod. So the most left image actually shows the camera. You can see the camera installed in front of the push-pull rod. The middle one shows the video live streaming that the technician can see during the pre-flight from the push-pull rod by moving it and verifying its completeness. And the most right image actually shows the additional layer that you can add on it, because once you have the videos and the images, why not help the technician and add algorithms that can do the analysis for the technician in a more professional manner that a simple technician would not always be trained well enough to find problems that are sometimes at the level of 1 pixel in this case. So what we did, we looked at traditional PHM systems, and we selected the right condition indicator, what is called condition indicator in PHM solutions. So in this example, you see there are 2 condition indicators for this sake that were selected. One is the width of the threaded area of this push-pull rod. It's the one marked in yellow. And the other one is actually the rotating angle of the nut that is connecting the rod. So by monitoring that, we will not only provide the technician a pass-fail notification of the inspection, we will also be able to add additional data and show the deterioration of the specific mechanism that is being inspected over time. So we have very limited time. I'll just show you briefly one of our earliest models that we used for the development of the algorithms. You see here the real push-pull rod of the Apache helicopter. And you see here the camera, the same camera that is installed on the Apache itself. And on the right side, you see what the camera sees. And you can see the safety line. You can see the safety wire that the push-pull rod has. And of course, there are a lot of condition indicators. And I'm sure that each one of you, when he sees this image, can think of a lot of condition indicators that can be defined in order to have condition-based maintenance and then later prognostic and health management of this specific component. So once we move to computer vision and to algorithms that even involve AI and machine learning, we need to train the algorithms. So one of our challenges was actually to use photorealistic methods that exist already today out there. But as Professor Khan showed earlier, a lot of them are used for automotive and for generating bigger scenes. And what we always say is that while everybody are looking outside the platform, we look inside. And the traditional methods of photorealism don't actually fit to our needs. So we had to develop our own methodology by taking 3D CAD models and creating these models to be as much realistic as possible, including simulation of the illumination, the camera sensor, and everything else that is needed to get to a point that you see here, that on the left side, you can see the real video that was recorded from the real aircraft, on the real Apache helicopter. And on the right side is the simulated video. And using this simulated video, we can simulate failures of the components to train the algorithms in methods that cannot be done using these kind of simulations that I've just shown you before of realistic, of real parts. Or of course, we cannot do these kind of failures simulation on the aircraft itself. And that way we can accelerate the development of our algorithms. So we talked so far about the advantage, the benefit of enhancing safety of the aircraft and of course, saving lives. But we're not just saving lives, we are also saving a lot of money, because a lot of money, as we all know, goes in the life cycle of a platform to the maintenance more than to the initial procurement of the platform itself. So if you take, for example, pre-flight, just the pre-flight section of an Apache helicopter, and we did this kind of a breakdown with the Israeli Air Force and try to analyze what part of the pre-flight we can actually take and move it to be inspected by computer vision and by our system, by locating cameras on strategic places around the aircraft itself. And we found we can save almost 50% of the time for inspection, and that way, not just reduce costs, but also increase the operational availability by shortening the turnaround time between missions. We developed eventually what we call the serial product solution. And what you see here is the computer that we developed. We have two types of computers, one for 8 cameras. This is the one that I show here. And the one you see in the middle of the slide is actually used for up to 16 cameras that has a lot more processing power. It has an NVIDIA SOM inside, NVIDIA Orin. A lot of you are probably familiar with it, but of course, ruggedized to military grade mil standard A10 and so on environmental conditions, with a lot of electronics that we have developed inside to provide a lot of interfaces in order to interface the avionics of the aircraft itself or any other platform that the system resides on. And another thing that we had to develop is the camera itself. The fact is that since everybody are looking outside and we look inside, we couldn't find any camera that will fit our use. And we had to develop our own cameras in order to include the right optics, the right illumination, and to have the right connection, like this connection here, that can provide long distance connection for high speed, high bandwidth streaming of video, while also providing the power on the same connection. So moving on from the aircraft level, we move on to the fleet level. In the middle, there is the technician tool that I'll show you right away that is being used to download the data and then also upload it to the cloud. We've developed a very flexible cloud architecture, or as I mentioned earlier in the Q&A session, that can reside either on commercial cloud services like AWS or Azure, or on government cloud or on local servers. And that, of course, provides additional layer and additional level to manage the critical components at the fleet level, and gather a lot of data at the fleet level, and to analyze it and actually perform continuous improvements of the algorithms using this data. So a very short demo, since we are almost out of time, is just this short demo here that I will show you. Is for a flying model that we instrumented with our cameras. And I have time only for one component, but we instrumented it with the cameras showing the critical components of this flying model as it was a real aircraft. And if I take, for example, the main landing gear, then we can stream to the technician what is the status of the landing gear, and see, for example, the status of the shock absorber on the ground. And when we add the algorithmic layer and add actually the condition indicators, we can provide a lot of data in real time and provide alerts to the pilot that are much more than just gear up, gear down, or gear in transition. A lot of accidents have happened for aircraft due to the fact that the landing gear was not going down properly. And with our system, we can provide a lot more data either to the pilot or to the maintenance organization before the problems happen, and try to predict them. And of course, if we're using a UAV, then of course we can use the data link of the UAV and also downstream the alerts and also the video itself to the operator in the ground control station. So one last demonstration is our technician tool, sorry. So the technician tool shows with a blink of an eye what is the status of the critical components of the aircraft as it currently detects. And the technician, when performing the pre-flight, can also access the live video feed from each one of the cameras. That's one option. And the other option is to go deeper with each alert that is detected. For example, if there is a leak alert for a certain oil connector that is being inspected, the technician can see the history of the alerts and the inspections for this specific component, and also replay the video that was saved just for the inspections that have failed.
Ido, we've got to wrap up. If you can wrap up for us.
Yeah. So just one last note I would say is that just one example of a use case is monitoring, for example, shock absorbers on a submarine, in order to make sure that we detect in time that the shock absorbers are deteriorating, in order to prevent hurting the secrecy of the submarine. We have a lot of use cases that we can detect with our system. Just one note is the Seahawk program that we are part of in Israel. The Israeli Air Force received the 5 Seahawk helicopters from the US Navy. They are being upgraded, and our system is installed as part of the upgrade of the system for each one of these helicopters. So to sum up, this is a proven technology that's already installed. We already are under serial production for different platforms, not just in the defense sector, as I shown today, but for also other sectors. And this platform can not just prevent safety incidents in advance, but it can also save a lot of money. So I don't know if you have time for questions, and if not, then I'll just like to thank you, and you can feel free to contact me either via LinkedIn or in any other methods.
And Ido, did you share your, have you shared a one-pager with the UK team that we're consolidating those to kind of share across the ecosystem? So if you did have like a one-pager, you could send that to us or to the UK team, and we're going to share that.
Yeah, so the UK team has our one-pager.
Okay. Well, unfortunately, we've got to move on to our next demonstration, but we really appreciate you dialing in. It's unfortunate you couldn't join the folks there in person, but we thank you for your presentation, and we'll look for that one pager too.
Thank you. Thank you
Thanks,
all.
Ido. All right, folks in the room, we're going to shift over to Fleet Robotics right now. So we can pull this, I might have to pull this table back a little bit for you, but if you kind of want to gather around there, we're also going to have it via my iPhone that we'll figure out how to make sure it's up here too, if you want to kind of stay there to see it. But I mean, this isn't a, yeah. So if you want to gather around, but if you think if people sitting can see it, that's fine too. I'll leave that up to you, Mitchell. Yeah. No, they're going to be second. Yeah, we're going to start here because he was already mic'd up here. Is he mic'd up? Is he good? No, not yet. Okay. Well, you're going to hold the mic too, but you're also going to get mic'd up. You're getting all sorts of mic'd up. So that's going to be yours.
Thank you. What do you want? Like this? All right. Good. Got the screen. I got everything. Yeah, right? Speak into the microphone. Okay. Hi, I'm Mitchell Weiss. I'm with Fleet Robotics. I'm here with Anjali, our product manager on this. I'm the COO of Fleet, and I'm trying to bring these products to market. So Fleet's about 2 years old, and we're still in the development cycle. We spun out of a Harvard Marine Lab, soft robotics lab in Harvard. And the product we're currently working on, which doesn't have a name yet, is this robot that is sitting here in front of us. If you can see it, yeah, this thing right here. Oh, trip on the cords. It's about 1 meter long, and it's got 2 big brushes on it. These robots walk on the hull of a ship. So there's switchable permanent magnets underneath the feet. And a switchable permanent magnet's a really neat thing. You can turn the magnet on or you can turn it off. And we use electricity to turn them on or off, but you don't need to maintain the electricity to hold it onto the ship. So it's a very efficient device. It's a 2-legged robot. So it puts a foot down on the side of the ship, spins around. There's a little video here running. You can see it walking on the side of a steel wall. It puts a foot down, it rotates 180 degrees, puts the other foot down, rotates 180 degrees, puts another foot down, rotates 180 degrees. While it's rotating, it's cleaning the stage 1 or 2 fouling off the side of a ship. Ships currently, think super tankers, think 300-meter, 350-meter long ships. Currently, when they're plying through the ocean, they're wasting about, when they get fouled enough, 15-20% of their fuel, just fighting the fouling on the hull of the ship. Ships typically get cleaned less than every 6 months because the ship owner doesn't want to take the ship out of service. And all cleaning is done, most cleaning is done in port in the water. If your ship's really bad, you're going to dry dock it, but no one wants to do that. the idea of something like this, and there are other people working on robotic cleaning systems, so you don't have to put a diver in the water with a brush and clean the ship off. This is a fully autonomous system. There's no interaction required by any of the sailors or the crew on board the ship. And it actually works on the ship while the ship's at sea, traveling through the ocean. So you spend no time taking the ship out of service to clean it. And because it can do it all the time, we can go out every week, every 2 weeks, once a month, and do proactive cleaning of the hull before the barnacles and the mussels and the nasty stuff gets collected. And the rate of fouling is a function of the temperature of the water, the sunlight, the sea level, the bio status of that water, the nutrient levels of the water, and everything else. So each ship will have 2 fleet robots on it, one on each side of the hull. There's a docking station that the robot walks out of and then down the side of the hull to the water line, cleans the ship below the water line, comes back, and while it's doing that, cleaning the ship along the water, below the water line, it's taking pictures on every step, and it's measuring the film thickness of the paint at 12 locations on each step, because we have magnets and we have magnetometers that measure the magnetic strength. We know the thickness of the paint on the ship. So we're collecting all these images and all this data and cleaning the ship. So the commercial customers are very keen on cleaning the ship because they save 15-20% of their fuel costs a year, which amounts to hundreds of thousands of dollars a year per vessel. And they're also getting all this proactive data on the condition of the hull, including the paint thickness. We are now working with the Navy on a phase 1 SBIR and working on a phase 2 to put this on naval vessels as well, because it's a readiness item. You keep the ship clean, and naval vessels spend a lot of time in port. Fouling really goes up as you're sitting still. So the first few ships will be on, we're deploying end of this year, beginning of next year. We start deploying in pilots, and then the end of the year we'll be on ships permanently. The first things we'll be deploying on are service vessels, the guys who service offshore rigs, pipe layers, and everything, because those ships are stationary a lot. But the customers who are really interested are the oil tanker guys and the bulkers. So oil tankers is just a money game. Bulk carriers like iron ore and stuff spend a lot of time at anchorage waiting for a job to do. They're kind of like the Uber drivers of the ocean. And so they foul up pretty badly. And none of those things, the tankers or the bulkers, or even the container ships for that matter, have crews that you can train in how to operate a robot or clean the hull. So the thing has to be autonomous. There was a discussion earlier about AI. We have 2 intended use cases for AI. One is we'll be collecting ship trip data. We have GPS on board, so we know where the ship is, how fast it's moving. We have a weather station on board, so we know the temperature of the water, the temperature of the air, all that stuff. And we'll be comparing that to the biofilm growth. And so we will start to, after we've had a couple of years of deployments, plan the proactive cleaning instead of doing it on a fixed schedule. We're also working with almost all the major paint and coating companies on designing the right cleaning protocol for their paint, because customers are more worried about ruining the paint than they are about getting the film off, although they should be worried about both. As we move to the future, Australia is already doing this. The US does it in California. A lot of ports restrict your ability to bring your ship in if you're bringing invasive species in. So you end up having to moor them offshore, send divers in to clean them before you can bring them into port. That's a really bad thing. So we're talking to the Coast Guard about letting them get the inspection data that this thing generates on the ship electronically transmitted to them from the ship owner, so they can just let them go through. It's kind of like global entry for ships. And then the second thing we're going to do with AI, again, we'll need a couple of years worth of data, is start looking at the images, and instead of just giving them to the customer, we're going to give them to the customer in a very data-friendly format, stitched surface mapped over a model of the hull and all that good stuff, and they'll be able to look at them. But what we really want to do after we've collected enough of this data and annotated it enough is actually point them to the areas of interest. So they're not spending a lot of time. And then for the bigger fleets, all this data will go up over satellite connections off the ship to their data sets, and the folks at HQ will be able to monitor it. So quick summary, two-legged magnetic robot that cleans hulls proactively and autonomously, so there's no crew limitations. We're going to be providing it to commercial customers as a robot as a service, so it has an annual fee to have it. This prototype here has a lot of ports and windows and doors and replaceable parts. The end product has no ports, windows, doors, and replaceable parts. Your robot breaks, we put a new one on board at your next port of call. Since this is a vision conference, there's two cameras, one on this side, one on that side, and there's two more cameras that look down at the paint surface, so we can do roughness measurements and things like that from teeny tiny images. These images, you can see the kind of stuff we're getting. It's going to be for the camera aficionados. The production version uses a 8 megabit Starvis camera, which is a Sony very low light sensitive camera. So that's the story. Questions?
Yeah, we have time for one or two questions if anyone has one. I'm going to give you a mic though, so everyone online can hear us.
So, hey, Dan Stanley with NAVC. So quick question on your magnets. How much testing have you done with thickness to paint that adhere to hulls? We've had some challenges with switchable magnets and thickness of paint adherence.
We're doing a lot of testing
Okay.
on this. This is our third or fourth generation magnet now.
Okay.
Each magnet provides 1,200 newtons of strength at half a millimeter, 50 microns.
Okay.
They are neodymium magnets and Alnico magnets, but they are not high temperature neodymium magnets, so there are no Chinese license export restrictions on them. And anyways, we bought 2 years worth a couple of months ago, just in case.
Okay. Yeah, I'd be curious to see how it performs with some of the thicker paint coat systems on the ship.
Well, we can't get above a half a millimeter of paint. So.
Any other questions? Yes.
Have you done any comparison against the amount of drag you reduce by biofouling as opposed to the amount of drag your robot induces?
You saying, have I compared the amount of drag the biofouling applies versus this robot? Well, considering it's a 300-meter long ship, my 1-meter long robot that's 2 inches deep doesn't do much compared to the 200 meters of fouling that's along the surface. So I read something that the Navy actually put together that like the front 30% of the hull is usually pretty clean because it's turbulent there, but it's the back 60% that's the real action item. And we're designing this thing to go to 30 meters. And it also can do the bottom of the ship, by the way, because in water, it's neutrally buoyant, so it's not upside down. The hardest time it has is actually climbing up the side of the ship when it's out of water to get to its dock.
So can you explain the power source?
Sure. No, it's not tethered. It's a 600 watt hour lithium battery. And the big question is, how am I going to get explosive certified for use on LNG tankers? Well, we're working on it. But the battery will be in a vented steel enclosure, so I have to deal with that.
We've got one question online and then we're gonna shift over to the Neptune Shield table. Is there a robot to robot communication protocol for interfacing with other robotic platforms? I guess not between the two robots that you potentially have on there, but other robots on board?
We are not using any industry standard. Our robots live on the ship's network, if we do. And we will be using Kafka as our messaging system for pushing data up and down. But there's no command set that goes from robot to robot.
Okay.
That's also a big kind of project that we're kind of considering with NAVC. It's been a point of discussion a lot in our SBIR conversations is how can we, especially with our system being on board, how can we communicate that to more specialized robots that are going to do the maintenance and stuff like that. And so we're actively working through kind of a plan of action for how we can do that.
And the deployment model for this on a ship, when divers go in the water, you have to get a PTW, a permit to work,
Yep.
from the captain. The robot talks to the bridge as a web page. So if there's a computer with a browser on the bridge, you open up the site that's the robot. When the robot wants to go on a mission, because it recommends that it does a mission of cleaning, it goes to the captain for a PTW. And if they don't get it, the robot doesn't go. If they get it, it goes. It's a one button thing.
Great. Well, hopefully you guys aren't running off. So if anyone has any other questions, they can walk over to their table. But we're going to shift over to Neptune Shield now. So give us a second to just get stuff shifted over, and we'll move on to the next demo. Thank you. I'll take that. Yeah, you want to grab that? You.
You're the best. Thank you. Hello. Bless you. I know it's going to be tough because I don't, I'm going to try. I'll do the best I can. Hola, buenos días, ¿cómo están? Good? Maybe you can. I'm going to navigate the machine, but I need someone to. Can you see the monitor out there? Monitor. That's all it'll take, I swear. All right. Good afternoon. I'm Carlos Odi with Reliability Center, and first of all, I want to thank Mid-Atlantic Tech Bridge and Neptune Shield for having me participate in this event. It's been great, and so I just want to say thank you very much. I'm only going to take up about 15 minutes to show you our EasyRCA tool and introduce you to our company, Reliability Center. So who is Reliability Center? We're based in Richmond, Virginia. We're a small company, but we're currently in 35 countries. We serve industries cross-functionally, meaning paper, pulp and paper, steel, manufacturing, oil and gas, petrochemical, and ports and shipping as well. So we have a very diverse set of customers, but not only across the customer profile, but within each customer, we work with the mechanical and reliability sector as well as the QHSE, quality, health, safety, and environment. So the tool that I'm going to show you and the methodology and approach that we use is very effective. Over the past 50 years, we've served over hundreds of customers, trained over 30,000 students, and completed 20,000 plus investigations for customers across the world. So what is it that we do? We're in the business of defect elimination, root cause analysis, and human performance. What that means is when a customer critical system goes down, we help them through training, consulting, and software to eliminate that problem by drilling down to the physical or the component level failure mode, to the human root, and then to the systemic. And then we want to make sure that something got better. So we help you track that the failure was eliminated. If you don't drill down to the systemic and only fix the physical component, there's a good chance that whether it's in 6 months, a year, or some time frame, that will recur. That issue will happen again. So that's the introduction of who we are and what we do. And because we do have only 15 minutes, I'd like to share with you our latest version of our software. It's powered by our methodology, our approach, which is called PROACT. PROACT has been around, like I said, for about 50 years. It's been very effective if you want to use it on very complex problems. Basically, what it is a cause and effect logic tree. And it's very heavy on verification and data. There was a lot of conversation earlier about data and the importance of data and how much data you need. In our experience, and I don't have 50 years with the company, but I do have 18. In my experience, the more data you have, the better. It helps the analysis goes faster. It verifies the information that you have, and it also secures and supports recommendations that you make after the analysis. It's super important in that way. So our latest tool is called Easy RCA. And it truly is an easy tool. It's a structured approach to defect elimination, and it uses a lot of the tools and OpenAI and vibration analysis methods as verification tools within the analysis to verify data. So we're a little bit outside the general scope, but we use all of the information that you folks are providing to verify data and make the analysis run better. So I'm just going to go ahead and start. We've incorporated OpenAI into our algorithm, into our PROACT methodology. And to that event, if you can see my screen over there, I know it's a little small, there's a little button here called Generate RCA Turbo. Now, this is a very cool new feature in root cause analysis. Because imagine if you're in industry and you're working in a facility or a plant, and you're walking through and you're a maintenance manager or an operations manager, and you see a problem, you see something that's broken, something that's leaking, you can take a picture of it now, or take multiple pictures. And in this tool, I'm actually just going to grab a picture. Well, that's not it, but this is. And I'm going to drag and drop a picture into this dialog box. I know you can't see the actual picture, but you can see that it says bearing JPEG. And I'm going to hit submit. And this is using OpenAI. And this is a great brainstorming tool, I think you'll see. Don't let me down. All right. And so let me just turn this around. Maybe make it a little bit bigger. Just by looking at that picture, the tool generated an entire logic tree, cause and effect. And so let me show you what the picture was. If I go here to the files, can you see the failed bearing? That's the only picture dropped in, but you can also drop in a vibration analysis, I guess, squiggly thing, graph, right? You can drop that in, it'll read that. It can do multiple things with that. You can type in a problem statement. It'll generate a tree. And so the beautiful thing about it is it's a brainstorming tool. It tells you that a bearing experienced catastrophic failure due to a loss of structural integrity and insufficient lubrication. And then it gives you several failure modes. Now, these may or may not be the exact failure modes. That's where human intervention has to come in and look at it. So AI is a wonderful tool, but you really do need a structured approach to look at it. And you do need people. And you're not married to this approach here. If, for example, we talk about excessive loading, but maybe there was fatigue. So you can always add nodes to this. And I will add one. And I'll type in the word fatigue. And from there, I can go to our template library. A beautiful thing about EasyRCA and ProAct is that we've got about 300 built-in templates across electrical, mechanical, human, and quality issues built in. So that's important because when I key on the word fatigue, in our templates, we can look at potential possibilities of what that could have been caused by. I'm just going to pick one here, high vibration. And click on it. And it's added, fatigue due to high vibration, due to misalignment, looseness, and so forth. You can go down and then apply AI to it and say, give me some suggestions. And it'll complete the tree all the way down until you get to corrective actions. So it's a very viable tool. It's super easy to use. We provide training on it. It's not that difficult. And then again, we have to verify. So we'll verify over here. And it's quite an easy process these days with the AI. And I'll say suggest a task on that corrective action. And it says it's establish a comprehensive installation process, because it identified misalignment as a potential failure that needs to be fixed. It tells you exactly what you need to do. You can assign to the responsible parties the task. They will receive an email saying you need to fix this, you need to complete this task in so many days, and you move forward with that. Once you're completed this process, you can go in towards the end and generate a quick report. What happened. You can always go back and update any of this data. You can go in, there's a timeline, summary of findings, tasks that have been associated with it, the tree that we built, the root causes identified, team members, and finally, the picture of the failed object. So it's a very useful tool, taking advantage of AI, taking advantage of technology that's out there today for verifications. It's been in use we've been saving our customers millions of dollars for the last 50 years. Also, we've used it in fatalities. We've used it in serious injuries. So it's very applicable today. With AI, it's helping us generate new thoughts, helping us expand what we know. And for large organizations, it's also a tool where it becomes a learning tool. And what do I mean by a learning tool? People come and go from companies and organizations all the time. And a lot of time that knowledge of the person who left leaves the company. So we have our own 300 templates that we've built into the tool, but the tool also gives the user and the organization the capability to generate their own tool, their own template, I should say. So if you complete an analysis, it's really good. It's been approved. It's been validated and verified. You can actually add it to your own template library so that other people within your organization at different facilities or different groups can search for it They can open it, they can copy it, make it their own. And then once they make it their own, they can actually modify it while the template stays in place. So it becomes a learning tool for the long run for an organization to become more efficient, to become safer. The tool is easy, so while RCA is often thought of as an arduous task, um, it's so easy to use that it's actually increased adoption in the RCA process in many of the organizations we work with. That's all I have. I'm keeping it short. If anyone has any questions for me, be glad to take them.
We have time for maybe one question. Yes.
So you mentioned using it as sort of a learning tool, right? Is there any plan or is there any way to sort of tokenize historical data so that you can correlate current failure modes into and sort of regress them to historical failures?
Yeah. So all the data all the analysis that you store, that you create, are stored in the application, in the cloud. We've added AI functionality for creating tasks, for creating a summary of the analysis by reading the tree and then creating a summary for you. We've added it with the pictures and problem statement to generate the logic tree. One of the next things that we're developing is the AI capability for the tool. Once you put in a problem statement for it to say, hey, you've got about 3 different analyses in your database already that are very similar to that. So that's in the next step. We're also we're updating our tree editor, you know, what you saw in that logic tree, to give you more flexibility to change the labels in that tree. So instead of saying event, it might say, you might want to put in failure, or if it's a safety situation, you might want to put in incident, right? Because that's in the vernacular of that organization. So yeah, there's a lot of things that we're looking at right now to take advantage of AI, to put that in place. We even use it internally with our team, our software developers, to, you know, if there's an issue or something, a flaw that they're looking at, they're using the PROACT methodology, the cause and effect, to identify what the bug was and then try to fix it when that happens.
Thanks, Carlos. All right, thank you very much. Now we're going to shift back over to Clay on the other side. So give us a second to shift back over there. Thank you. You did great. Great. I know. Like, I'm looking with her chin.
This is our first. Okay. All right. Let's stick it right here, and I'm asking it to say like 3 sentences.
Yeah. Test. Test, 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 test.
We can hear you online.
The slide deck, I think. Yeah, yeah, that he's sharing.
Yeah.
And you. Slide deck?
All right, folks, we're gonna turn the floor over to Clay. So if he can have your attention, please.
For educated babysitter at this point, man, I think you just kind of snag it at me. Can you just?
Fantastic.
Clay, the floor is yours.
Hi, everybody. Thank you for your time. I thought those were my sunglasses. All right, so my name is Clay Grunke. I am the owner and CEO of Humana Machina, which is human machine in Latin. So human first by design. So one of the things I'm trying to do is come up with better ways for us to interoperate with machines. Okay. So big picture, what I'm going to do is come up with the problem statement. I'm going to narrow it down to the first use case for the Navy and then expand out a little bit. Okay, so this gives an example of the complexity of this problem. So if I wanted to get a sailor or any human or any machine to navigate to this specific rivet, how could I do that today? We can't, because we're trying to convey information in words. Words are a poor medium for precision. So we'll get back to this. So you can think about it like this. So I'm going to give an analogy to the problem. So think about what it was like growing up 25 years ago, how we used to navigate around town. We used to do it by describing. So when you went to your friend's house, you would end up describing point by point how to get from your place to their house. You know, go up the road, you're going to take a left, go up the street, you're going to see a barn, take a right, right? It's this sort of landmark-based navigation that we're so used to. But then we saw GPS start getting integrated on our phones, and then we saw objectively we knew where we were, right? And so you've seen just this cascade of improvement when I have metadata that I can share between you and me, and not just between you and me, I can share between us and machines. So just like I could drop a pin and send it to you to get to anywhere on Earth, I could send that to a drone to get there. But let's think about the other half of our lives, right? So inside of facilities, ships, aircraft, these other complex coordinate systems where GPS won't work. So how do we do that? So currently we take our documentation, and what it requires is for people to read it, go through their own mental model to understand where it is, and then go out to the aircraft or ship to find it. Now, the issue is that is a huge problem for translational error. Conversely, on the other side, let's say you see an issue with the aircraft. We then have to load that into our brain and then encode that. So you're going from 3D back to 2D. So you have this double translational error here. This is what is eating our lunch right now when we're considering how long it's taking for us to get out of installs for ships and what's eating us alive with maintenance, specifically with corrosion. So think about from this aspect, all of our documentation, we're basically stuck, we're capping out at what MapQuest was, 20 years ago, right? Think about all the improvements that we've had with Waze, where as we're driving, we're getting updated metadata. None of this exists right now in these other coordinate systems. And that's what I'm solving. Okay, so the direct analogy is you have the GIS system, you have layers of metadata. What I'm able to do is take 3D models or spatial representations and layer metadata on top of that I can share between us. So now I could take your documentation, I could put that on a spatial understanding, and now we're going back and forth with that model versus our own understanding. Okay, so I'm going to show the MCADs, which is basically the Navy's implementation of it. So I'm working with NIWC Pacific and FRC on the implementation. From a security side of this, NIWC Pacific would be holding all the layers for this technology. We're also working with them to integrate with all the current systems, meaning PIMA and stuff. Okay. So I'm gonna have a couple demos here. So this shows an example of a spatial representation of an ETUC Hawkeye. Right, so we have different layers of metadata that we can think about whenever we're looking at aircraft. Right, you see different parts, panels, all these different things. And what we're able to do is encode information on it. So this is an example of having a layer that's describing the aircraft zones. Right, so anywhere on the aircraft, I can have a specific layer for this sort of semantic data, right? And think about this as mutually exclusive. So I can paint any number, n number of potential IDs onto there. Okay. And so here's an example of painting door locations. So we're able to take basically their documentation for doors, put it on there and put it on spatially. And it's one of those things where we can query those information layers. So here's an example of us querying it and it telling us objectively what we're actually looking at. So instead of me inferring what I'm looking at, I'm able to go the opposite way, like GPS. GPS tells you where you're at. I'm telling you what you're looking at. And that's how we reduce a lot of the errors and assumptions that we're making. Okay. All right, and so I can use different systems for this. So like I was saying earlier, I worked with NIWIC to come up with a LiDAR model. So there is no OEM dependency on this, critically for the Navy, right? Because the OEMs are not going to give you guys anything. But this is a way to actually start rolling your own digital twins. All right, so I can do it not only on LiDAR, I can do it on photos, I can also do it on static documentation. So the point, one of the things I'm trying to do is how do I go from zero information all the way up to engineering grade within hours? Not years, months, hours. That is what I'm trying to do. See how my pacing is here. Okay. All right, so we've been working with NIWIC and FRC with this. I got my display settings here. Basically being able to compare the status quo to now. So it can work on our current devices. It's basically able to slash our documentation time. So the part I got to show you on there is, since I know where all those layers are, and I can just mark up where discrepancies are, I can procedurally generate our documentation and you can audit it, right? And so basically that cuts down what takes 6, 8, 10 minutes to do a typical maintenance action form, I can do in less than a second for thousands, because I'm doing this on the GPU. And it's also makes it more objective. And then I think one of the real key parts about this should be in interest for all the ML folks here. I'm making that data structured, right? So I can go to this specific point and I can look up any layer of information underneath it. I can take a look at our X-ray data and compare that to our ultrasonic data. I can compare that to human-derived findings of when we mark things up, right? So how do you layer those things? So, and that allows us to have a better ability to use AI on top of that. So right now we're trying to use AI on top of words. Words are subjective by definition. So you're never going to get objectivity with it. But if we're able to structure that from a foundational standpoint, that's when we're going to get some really good stuff on the other side of this. Okay, so live demo. Working. Got to hold. I haven't practiced holding a mic while doing this before. Where is that? Nope. Oh, there it is. Okay. All right. So here's an example where we're able to do labeling. Oops. Let me mark that off. Right. So effectively, what you're able to do. Okay, 2 hands. Is effectively you just color, you just paint, right? So if you can paint, you're automatically qualified to label objects. And so that's the other portion, is you're doing labeling for computers, right? So I'm able to spatially label or spatially color where all these things are. So where are we calling this specific object? And it's just as easy as painting, and this is a one-time cost, right? So have your engineers officially label, what are we going to call this thing? Instead of training thousands of people, same thing, let's label it once, just like outside, You know, when I'm using Google Maps, I go to a specific spot on Earth, I get all the metadata. We have that objective layer of metadata we are all sharing going back and forth. Sorry. Not if I talk really loud. Oh, okay. But the other part about this is not only can I do that with that labeling, I can also put your NDI data, right? So right now, when we're doing NDI inspections, it requires a human to take that and interpret it and then put it in our documentation system. It's air gapped. How do we connect that system? Oh, I thought I was getting the curtain call already. Okay. Okay. And I can do this with everything. So let's say you have imagery, you know, you can send that, you know, to some algorithm, come back, have it label it, and again, you're doing all of that. You can do again multi-sensor, so you can do IR. So multiple different things that you can do for that. So any number of information that you can put onto the model, we can do that. Okay, so as long as it's logical, we can do that. Okay.
So Clay, you've got about 4 minutes.
I'm worked it. All right. Okay. No, I'm good. Okay. So again, so I can take that information, and then I can procedurally generate the documentation. So here's an example of that where I'm doing the labeling, and then here is me parsing it. So within, you know, that 1/10 of a second, imagine dividing your aircraft and shipped into tens of millions of pieces. I'm tracking every single one of those spots. So within that partial of a second, I'm able to use logic to generate maps for this. And critically, not only, you know, you have basically a single source of truth that you can affect your downstream documentation. So here's two different systems, UMA and DIR, that I'm showing I can write into. And this is all logic-based, so you can audit it. So you can have confidence in what you're actually showing. All right, so here's like an example of showing you that. Okay. So additional stuff, and then I'll stop. Okay. So because I know where all this information is, you can audit it. So here's an example of me checking the fastener with the actual documentation. If I need to change it, I change the labeling. That change cascades all of my documentation. Right now, you guys are chasing things with paper. It's not going to work. Also, because I'm having all this information in 3D, what I can actually do is query those information layers and get information back. So let's say you're looking for a particular thing, like a particular item. I can query my layers of data and pull back the 3D location in space for that, right? So I can show you where something is, right? So this is all at runtime, again, using the GPU, looking through all those millions of different points and things, effectively instantaneous. So not only can I do that, so when I have that, not only could I give that information to a human, so be able to say in augmented reality, be able to show you where that location is. But what I'm working on is I can also send that information to a machine and send it to the same thing. So instead of using inference, using maps as a way to have us using a common language to go back and forth. Talking back and forth between us and robots is not going to work. It doesn't scale. So you need a common frame, a common map that both humans and machines can navigate with. So there, I'll stop with probably 1 minute left.
Thanks, Clay. Any questions for Clay? Ooh, Dr. Senna.
So you talked about being able to kind of, as a user is manipulating on the screen, generate that documentation kind of for the classical methodologies. Are you able to do the reverse on take all this mountain of paperwork we've generated over the years and create digital models so we can kind of track what has been the maintenance from a visual standpoint to really go back into training and say, hey, these are the things that are common. This is what it's going to look like in that maintenance cycle for familiarity.
So I think I'll do my best to answer that question. So the documentation that we currently have, I don't know how much I trust it. And the engineers don't really trust it as well just because of the way it's been labeled. there's still some use out of that old documentation, so you could probably come up with some good generalizations. But you know, it's questionable the amount of stock that you want to put into that. Now, what I'd say also going forward is since you are effectively able to start capturing these snapshots in time with documentation, talking to the folks at FRC, they think this is going to revolutionize the way that they do predictive maintenance. Because now you can actually, at runtime, do queries, you know, within a specific part of the aircraft, something we could never do before. Right now, they take about 2 years to figure out what are the issues that they're having on the jet. And they're doing this basically through Tableau word searches. So imagine showing up a bunch of heat maps. Yeah, forget. So imagine showing up a bunch of heat maps where now I can look at, you know, prior prior maps and our current maps and actually get you the delta, right? So it takes you from the people researching this, it highlights kind of those issues a lot faster, and it's easier for us to understand as humans. I probably really did a poor job of addressing your exact question, but I can take that offline with you.
There's a lot of mean time to fail data in the Air Force and Navy and stuff like that. So what if all of a sudden, because your supply chain changed, your mean time to fail starts really shifting to not 10 years, but 1 year? And you have interrogation to say that maybe something got put in there that wasn't in there before? Do you have an ability to do that, to track that kind of mean time to fail?
So once you start having the data, like the data is there to be mined. Like it's giving you an objective layering of that information. So I would say, yes, you can do the analysis based on that because spatially you know where that is, you know what the object's called. So it's just, you know, doing the data harvest at that point or the analysis.
All right, we are going to shift over to RDI Technologies. So give us a second to shift back over. And then we've got 2 online presentations, and we're going to try to get the ODU team hooked up to the computer to show you a couple things. That's up to you. What do you want? Well, we're going Zoom. Do you have the Zoom info?
Yeah, can you send me the link?
Yeah.
I'm gonna do a live demo, right? You actually gonna send me the link?
Yeah, I got it. And then make sure that you let Franken. He's coming in. Okay, I think it's And Nitin, we'll come to you after Frank's done online. Bottom. Yeah, yeah. Oh, is it? We're good. Yeah, Frank, we're good. Is your computer volume off just so it doesn't echo? I think so. Okay, perfect. All right. All right, so over to Frank and RDI Technologies.
Okay, here we go. So, Frank Vitucci, I'm the regional manager for RDI in the Mid-Atlantic and New England region, but I'm also the aerospace and defense kind of like SME director as well. So, I have a quick question for the audience. Just if you can raise your hand, how many of you are actually familiar with vibration analysis? Okay, so a good handful. So for those of you who are not familiar with vibration analysis, it's basically a means of being able to diagnose a machine, whether it's rotating, static, it could be a jet engine, it could be a diesel engine in a ship, or it could just be an industrial motor, pump, pipe in an oil refinery. So vibration analysis gives you the ability to diagnose for specific types of problems. It could be mechanical looseness, it could be misalignment, it could be resonance, it could be imbalance. So the conventional way right now is to use a sensor and a data logger or an analyzer, and you walk up to a machine, you take measurement points, and then a trained analyst is able to look at a plot that shows frequency and amplitude. Frequency identifies the fault. So if the fault is mechanical looseness, it has a unique frequency. Amplitude tells you how severe it is. So that's your basic 101 vibration analysis. We'll have a test later. So motion amplification is not meant to replace conventional vibration analysis. It's meant to complement it and to help visualize faults that the human eye can't see. So what this technology does, and I'll show you this live, is two things. It uses a high-speed camera. Within the high-speed camera, this particular one has about 2.5 million pixels. We convert those pixels into non-contact displacement sensors that are measuring 2D. So we're looking at horizontal and vertical motion or vibration. We also can look at this in 3D with our two-camera system. So if we look at this live, right now, for the sake of the demo, this helicopter is vibrating because I have a little fan underneath it to make it vibrate. The human eye can't see that. Put my glasses on real quick. So if I go into this live, I can actually show you really quick how it's moving. Not playing back very well, is it? Let's see. I think there's a delay between the computer and Teams, but right now, if you want to get closer and look at my computer, you could actually see the blades are deflecting and the airframe is deflecting. So we're able to show you first live how that machine is moving. But you could also quantify it. So if I wanted to take a measurement, just like with conventional vibration analysis, I can draw these little boxes called regions of interest. And I could actually extract vibration data. I can extract time waveform, I can extract frequency and amplitude. So this is where a trained analyst could look at that data and start to diagnose and try to figure out what's wrong with the machine. In the case of the helicopter here, that vibration from the fan is causing the airframe to move, the blades to move. So we had this other technique called filtering, and I'm going to switch screens here for 1 second. So now I have my raw data. Hopefully it plays back better. Wrong screen, hold on. There we go. So there is a delay here. Let me speed it up and see if that changes anything. So you can see how those blades are deflecting right now. If I were to turn down the amplification bar, that would be the raw video or the live video showing no motion. And then if I amplify it, you can start to see the motion. I could also add what's called motion vectors. So it's just another visualization tool. Turn those on. So what the motion vectors does is it actually shows you the direction and the magnitude of the motion. So if you're a design engineer, if you're a vibration engineer, or even someone that's non-technical and not familiar with vibration analysis, these tools are to help you figure out how something is moving and how that vibration may impact the product or may impact the application that you're measuring where you're trying to solve a problem. I can also look at data. So if I wanted to look at conventional vibration data, I can bring up frequency and amplitude. And then when I see something that does not look normal or different from the other signatures, I could look at that and say, that looks interesting. What is that vibration? Where is it coming from? And I can filter it. So if I go to filtering, I could pick that frequency. Pick my filter, apply the filter, and what we'll see now is we're only going to see the motion at that particular frequency in a helicopter. So this is where it helps you get down to like root cause analysis, failure modes. So now we're only seeing that frequency, which was like 42 hertz. So a lot of times, especially with ground vibration testing, or if you're doing full engine analysis, sometimes engineers or customers are looking for specific faults at specific frequencies, or it's a new product, they're running it on a test cell, they're doing mode shapes analysis, they're trying to understand how this product behaves when it's running. They may have built a model that simulates what these vibrations look like, but until they actually see it in true life, here they're able to validate that it's either within the model or something is abnormal, and they need to design out that problem, isolate it, dampen it, etc. So I would say the biggest value and benefit of motion amplification is probably communication. It's the ability to be able to visualize and show a problem with vibration that traditional vibration analysis can't really show you unless you're a trained analyst and you're really experienced at looking at data and know how to convey that information to someone. Where with the video, if you're technical or non-technical, it becomes much easier to be able to not only see a problem, but solve a problem. How am I doing on time?
You got a couple minutes.
Couple minutes. So any questions?
Due to the fact that you're using a helicopter in this, can you do this with a live turning vibe analysis on the helicopter?
Sorry.
Or does it have to be static? What you're doing, does it need to be static or fixed, or can you do it like on the rotor blades? Because we do a vibe analysis on the rotor blades as it is. Can you do that with a turning aircraft?
Yeah, so we have different methods of measuring static, rotating. With rotating, we have a really interesting technique where we connect that camera to an external laser tack. And what the laser tack does, it synchronizes the camera to look at the rotating. So if it's a blade, a coupling, a shaft, it actually freezes that synchronous motion. And then anything non-synchronous, we can measure, amplify. So if you had a blade, for example, and you wanted to see how those blades were flapping, if there was some kind of a looseness between the blade and a hub or crack, some kind of a deflection, visually it would look like the blade isn't rotating on the video, but it is. We just froze that synchronous motion, and then you could draw those little boxes, the ROIs, and extract vibration data. A lot of people will say, well, I can do that with a strobe light, right? Absolutely. You can put a strobe light on something that's rotating, and visually it looks like it's not moving, but you're not going to take an accelerometer and put it on that blade while it's moving, right? Because this is non-contact and we're using a camera, we're able to record that video of a blade, and then we, in post-processing, we can go back and say, I want a measurement on this blade, on the shaft, the hub, and actually analyze and see how that thing is moving.
Thank you, Frank. Really appreciate it.
You're welcome. Thank you.
All right, we are going to shift to Nitin and Dory AI online. So Frank, if you can stop sharing, and Nitin, if you want to start sharing your screen, you can do that. And then we're gonna, MSI we'll have after that, and then we're gonna see if we can get the ODU team hooked up here without any internet. Nitin, are you there?
Hi there, Tina.
Okay, great. Do you want to go ahead and are you going to share your screen?
Are we ready to go? I can go ahead and start presenting. Just give me a minute here. Just give me a minute. I need to restart here, the Zoom. Tina, are you able to see the screen here?
Yeah, we're ready for you. We can see your screen.
Okay, great, great. All right, appreciate everybody joining here. My name is Nitin Gupta. I'm the Vice President here at Dory AI. We at Dory are a company that focuses on enabling real-time visibility into ground operations through the use of a technology called computer vision that has been leveraged in a number of different areas. As a company, we've focused heavily on the manufacturing and logistics sectors, but the technology and applications that we have are broad in terms of its industry applications and even certain government applications as well. And what we found is that there's a lot of common issues that most enterprises face in terms of trying to get that visibility in real time. And leveraging this type of technology is a quick and easy way to enable your team to have that ability to make those real-time decisions, but also leverage this to even track various types of analytics or operations. And so what we see across the board is that there are three key issues that most teams are trying to assess on a day-to-day basis when it comes to these operations. The first is to enable your team with the ability to actually have that visibility, whether it be enabling them with tools and utilities to actually make those decisions. So for example, in a manufacturing setting, being able to assess the quality of a product or whether an operating procedure was done correctly or not. These are all things that now with a simple camera, you can actually process that through AI software to be able to do that assessment for you in an automated way. But then also in terms of enabling from an efficiency or costing perspective, can you do things now much more quickly in order to reduce, say, for example, the amount of time that something is not being utilized or is down. And so the way that we at Dory AI operate is we actually leverage off-the-shelf cameras that are placed in and around your facilities, or in the case of the Navy, it could be even within the vessel itself. And we're able to monitor in real time these operations. And the purpose of that is to really, one, ensure that you are compliant with whatever the operation is at hand. So a lot of our clients have standardized work instructions or very specific repeatable procedures that they need to execute. And in order to ensure that everything goes correctly, we have the ability to actually monitor that in real time and enable then that real-time feedback for that person who's executing that process. And I'll show you a couple of examples of how we can do that. We also have the ability to do those quality checks that may be done currently manually through a visual inspection. We have the ability to right away provide that feedback of pass-fail result. And what we see these types of applications being used is in contexts where you sometimes have a lot of even variability in the product or the process itself. And so AI has been able to evolve to enable that more objective way of assessing the quality of a product, be it when it's manufactured or even when it's going under some sort of maintenance after it's been assessed. But then the third aspect is really about traceability. A lot of our clients have to ensure that that visual traceable record is there at every step of the process, be it in the manufacturing setting or even in the maintenance setting, to make sure that there is a visual record of everything that has been executed on that particular part or product. And so we have the ability now to enable that traceability and that ability to even look up after the fact in terms of a log of history. And so within Dory, what we've been able to do is to create a suite of different applications depending on what specifically you are looking to monitor. It could be monitoring a standard operating procedure and making sure that things are being executed correctly. It could be specifically doing a pointed inspection to make sure there are no defects or there are no issues with the product. It could be a live monitoring scenario where you're just even looking at, for example, gauges or temperature settings, things like that, to make sure that everything is operating correctly. But then because you're also monitoring this stuff in real time, now you even have the ability to even assess the overall productivity of some of these operations such that you can marshal your resources much more effectively. So for example, if there's an area that's not being currently monitored, or there's supposed to be a station that's supposed to be occupied by a person, but it's not, these are all things that we can set up alerts for and then enable then those resources to be effective immediately. And we built the solution in mind that it could be deployed in a variety of different environments. So architecturally, we do have the ability to basically connect these, what we call quote unquote dumb cameras, to this intelligent AI software. And that software can either run on the cloud, it can run on-prem, it can run in a hybrid manner. And so alluding to some of the questions that came in earlier, we now have the ability to modularize this software such that it, one, can ensure that you're getting that immediate response time. Two, that you can deploy it in a much more centralized way. So that way, then, even if you're managing it across different sites, the same use case or the same application, you have the ability to even have that top level view. So for example, if you're managing a bunch of fleets, we can actually set up a system such that you can actually monitor each vessel and each equipment on each vessel and get that live full view. And depending on who you are in the command chain, you have the ability then to be able to even segment that out and say, okay, this vessel, you only need to view the status because this manager or this operator or this officer only needs this view. So we have that built into the system. So that way, then you can quickly scale and keep on adding the same use case, for example, to other areas or other facilities. Now, in terms of the types of use cases that we can service, again, we have the ability to provide that live feedback. So what you're seeing here is a manufacturing facility where we're actually monitoring all of the individual steps and SOPs that this operator needs to perform. So what we do as a team, we actually train the AI software for you. All you have to do is provide us access to that camera, and we'll set up the secure environment to basically collect that data, train the software, deploy it. We manage that fully for you. And we work with our partners to basically set up that secure environment. And so what we then can do is modify this and actually have a standard way for your team to actually visualize these SOPs so that they have that immediate feedback of what's being executed correctly, what's not being executed or missed out. So they'll get that immediate feedback in a dashboard or even an alert right on site. And then you can then use this even to train new operators or new people who are actually going to execute this as well. So it helps to speed up the training. It helps to make sure that the operation is compliant and that whoever is executing that SOP is very objective in that step-by-step process. And the same goes for even quality inspections as well. So if you're either producing a part or even maintaining a part, just making sure that that particular part or product is met those quality gates visually, we can actually set up and configure the system in a way such that one, you get that common way of viewing those pass or fail criteria, but then be able to fine tune for that particular part or product or process. And so that way, then, doesn't matter what the product is or what you're actually inspecting, your operators have a common way to do that across the board. Now, when it comes to equipment and asset monitoring, again, here's where you want to enable your teams with that live view of what's actually happening in the field. And so whatever the process is or equipment or asset that you want to monitor, we have the ability to train software to recognize what is expected behavior, what is not, what is, say, an expected gauge reading or not. And we have that configurability built into the system. So if you look at this instrument panel on the top right, we can actually place just a simple camera there instead of having somebody just stand there 24/7. Now you can just put a camera there and it can automatically monitor each of those gauges. And we can set up configurations for each one of them to say, okay, if they are out of range or not out of range, then we can signal an alert or enable for that to be continuously monitored. And same goes for any sort of maintenance operation. We can even give you analytics and alerts whenever, say, something does need to be maintained or whenever somebody does come to actually service that area. So that way, then you have that historical visual record of when those things actually were executed. And so then as you're collecting all of that data, then we have that telemetry data so that you can even pull that out so that as you're trying to look for process improvements or areas where you can potentially optimize, you have the ability to get those analytics and see, okay, how much of the time was this stuff being utilized? How much of it was down? How much of it was idle? All of those areas you have the ability to kind of pull up those historical reports and then provide both your operations teams as well as upper management with that necessary information. And so basically, as a company, we provide three primary interfaces by leveraging, like I said, these simple cameras that are then processed through the AI software. From there, it generates three different interfaces. One is a real-time alert. So whoever's there at that site, at that station, or at that particular facility, we can trigger those lights or some sort of warning signal if there's something that's not going as expected. The operator themselves would have that simple interface that tells them what that decision is that the AI has generated, be it a quality inspection, be it an execution of an SOP. And then all that historical data can then be pulled up in terms of analytics. So that way, then you can use that for overall process improvements. And so the way the system operates is each of these cameras that are connected to the system, be it locally on a server or streaming up to the cloud, you simply need to just provide access to a camera, and then we take care of the rest as a turnkey solution. And then that can further be integrated with other systems that are either on the vessel or on the facility, as well as generate those signals that can then drive some of those other alert systems that you may have in place. And we always do this with security in mind. We're not going to deploy something unless we've gone through that proper security review with your team. So any requirements that you have, our team will assess that and then work with that ITsec team to ensure that data is authenticated, that it is encrypted, and that the entire system end to end is secure. So that way then your data is protected. And even from a privacy perspective, if there needs to be some added filters and things added to whatever we store, we have the ability to also plug that in and ensure that those compliance requirements are met, be it GDPR, be it where data is stored, the way data is transferred. We are compliant with all of those requirements. So that way, then you have a fully secure and reliable system as well.
Nitin,
And
we've
so I
got just a couple more minutes.
Sure. And so at this point, I just want to kind of open the floor to any questions that people have. Again, my contact information is there if you wanted to reach out to learn a little bit more about how this might be useful in your environment, but open the door for questions now.
All right, sounds good. Any questions for Nitin, Dory AI? You can tell we're coming to the end of the day. It wasn't your presentation, but yes. And Nitin, did you, if you send me your one pager, again, I'm going to consolidate all those to share across the pond and with the participants here. So
Sure.
I don't know if you've sent it over to me yet, but if you can, that'd be great.
Yeah, I'll send it by end of day for sure.
Okay, perfect. Well, thank you so much. We really appreciate it. And at this point, I'm going to turn it over to Tim with MSI. And you can share your screen from right there. And then again, we'll see if we can get the ODU team plugged in really quick after this too.
Thank you, Tina. Oh, I do have to get close. All right, thanks everyone for staying this late. I paid the extra $0 to end up at the podium. So I'm a special guest here. So I'm with Mechanical Solutions. We are known primarily for rotating equipment, machinery, troubleshooting, design, analysis, and support of that with other companies doing those as well. But what we're really going to be talking about is our tools that we've developed for our toolbox in those efforts that are all camera-based, so our vision-based situational awareness technologies. Okay, so what we do and what we offer is these camera systems that are able to capture and perform analysis on dynamic events and targets, automatic tracking of things, and we do it over a very large dynamic range. So meaning, for in the mills or sub mills to miles. So we can also combine this technology with, we're mostly in the cameras, but we've kind of designed it in a way that is quickly applicable to IR, thermal, and X-ray. I know there was a question about that in the morning, and it is theoretically doable, just needs to be done. Okay, so our current product portfolio includes VibeView, which we call motion magnified video, and that's actually similar technology to what Frank presented, motion amplified video, and very similar to what Sergeant Bud and Ryan Halick were talking about at this morning's meeting. So I'm not going to go into too much detail of that, but it's generally about vibration characterization. I'm going to talk more in detail about TrackView, AlphaView, and our other custom commercial solutions and defense solutions. So a quick graph here just kind of shows the range of motion that it's looking at. So, how far away and how large the motion is from micrometers to miles. I don't know why we have in kilometers, but maybe for our British friends, and the time scale of it. So, there's ultra fast to things that take, it says 1 hour here, but we do recordings for 24, 48 hours, pretty much however long the test needs to be done and how much the computer can hold in terms of data. So again, I'm not going to talk too much about ViveView because it's kind of been talked about in detail. I'll just show some quick things about it. Generally, you just take a high-speed video of the equipment while it's running, and it can get auto processed and kind of reported out the motion of that piece of equipment. So I'll just show one of our videos. This is the dry pit submersible pump. It pumps sewage. So everywhere you go, these pumps are pretty much everywhere, and they have a ton of vibration problems. So let's see if this is coming over. Yeah, it's a little jerky, but you can see the motion there. Again, very similar to things that have been discussed today, so I'm going to just keep pushing through. Okay, obviously there's a lot of this in the commercial markets for any kind of rotating equipment, vibration troubleshooting and analysis, piping troubleshooting, anything in kind of the rotating equipment sphere. In defense market, there's a number of things very similar in nature, but you know, with its own special difficulties, of course. Again, going through this pretty quickly because we've talked about it so much, but the technology has a lot of benefits just in terms of non-contacting, relatively quick setup and analysis to get millions of data points anywhere in the screen of your video. You can get a vibration data point. Okay, so that brings me to TrackView, and this is where we use multi-cameras usually to do kind of large-scale motion and object tracking, where we're looking at things that are moving maybe very long distances or actually very small distances, but it's not vibration in nature. It's like one-dimensional movement, or back and forth. So this is a steam turbine at a power plant. It's an overhead view of it, and we put little stickers here. It's hard to see them, but the colors indicate where we are tracking, and we are recording the startup of this steam turbine. And as the steam turbine starts up, it grows because there's a lot of thermal growth because of that. And it's meant to. It's designed to do it, but in fact, this turbine in particular was having a lot of rubbing issues and machinery issues because it was growing cockeyed. So they couldn't identify that very easily in the field. So we were able to watch the startup of the turbine over the course of 12 hours and evaluate how and when that kind of cockeye is occurring in the startup of the equipment, so that we can tell them some answers in terms of where the sliding mechanisms are not working appropriately. And like I said, this is one view we're showing here, but it has multiple camera view optionality that everything can kind of be spliced together to get this kind of information. So in the commercial market, it's like I said, it's thermal growth monitoring. It's shaft alignment troubleshooting, meaning hot misalignment, like I described. Similarly, the offline to running transition monitoring, as well as piping and structural creep detection. So anytime you turn on maybe a pump or a compressor or something, you're exerting some level of pressure, and that pressure is a force, and it's very hard to detect normally, but when you have a piece of equipment started, it kind of will jerk in some small amount of way that can put it into a different dynamic state than when you measured it when it was turned off. It's very useful in the commercial market, and there's really not a different market in the defense industry. It's kind of the exact same stuff in terms of machinery maintenance and diagnosing problems. Okay, so when we say high measurement accuracy over a large range of motion. So the accuracy is in the sub-mil, so 0.5 mils accuracy for a fairly large range of motion. That turbine itself was maybe 120 feet long. It's detecting sub-mil motion over the course of that 12-hour. It is, interestingly enough, very different from the motion magnified video technology. It can use very cheap cameras and it can use security cameras. Since everything's moving quite slowly, it doesn't need to be that good of a camera. So as long as you have a stable camera looking at a piece of equipment over a long period of time installed, hopefully with some targets on it to help you process the data, it's able to do its magic. And that magic includes, either slowing down fast events that happen, some kind of transient event, or speeding up things like in the case of that startup where you're seeing something happen over the course of 12 hours. This is used a lot for in labs, testing grounds, and wind tunnels. Looking to get a little bit more in terms of using it with other existing systems as a CBM product. Right now it's all standalone, but it has a lot of potential to have an installed camera and installed in a CBM system that can also feed extra information into to a customer. Okay, so next is AlphaView. It's a different software as well. This is 3D and 6D multi-target optical tracking. So this is over a much longer range. This is over 1 mile of range, and we're getting, still good accuracy, but half an inch is not quite as good as half a mil, but 1,000 times worse, actually. So what AlphaView is doing in this picture here, this is a ejection seat testing. So we have a rocket sled, and we're just watching the ejection of the seat, and we are just checking for position, attitude, shape, and event timing of that ejection. And so in the 2D, you're looking with one camera. You're only ever getting 2 dimensions in one camera. X, Y, and Y. You're not getting depth because it's a camera. But when we go into several cameras, we have 3D position tracking, and so that's when we get X, Y, and Z coordination. And we can tie that into GPS coordinates as well. And then when the real interesting stuff is when you get into the 6D, which adds in yaw, roll, and pitch angles, as well as that X, Y, and Z. And then now you have a full 3D comprehensive view of something going on. And where it's really important for this testing is it's just determining if that dummy gets ejected, are you going to break its neck? Like you can tell how bad the angle is of the neck as it gets ejected. So similarly, for the commercial market, there's crash testing for automotive industries, similar with the dummy and just seeing what the impact of it will be, as well as just tracking of falls and the other training tools for athletes. Defense market, we do a lot of that egress testing and the rocket sled testing and missile testing for different military bases. And that brings us to our other products, which are a little bit more military only. So we were just calling it other right now. But this is for fragment tracking in arena testing. So you're getting ultra high speed video acquisition to watch fragments as they explode. And we can characterize all the motion and size of all those particles as they pass, what comes first, what comes next, what's the size and direction that they're all moving in. Sure. I got like 2 left. Also, we have missile attitude tracking platforms, target identification and recognition, where we can use AI. It's fairly simple AI compared to what you guys talk about here, but to target friend or foe and actual weapons versus as other things for weapons platforms. We also mentioned this warhead testing. We also have digital twin test planning as part of this platform as well, where we can support arena testing for different military installations that can plan their testing a lot better. Instead of iterating many times, you can plan it all in a digital twin space so that the testing gets done once and is correctly done in the first try. Okay, so a little bit more about MSI. We're just a small business. And we work on a lot of these vision-based programs. We have all of our software software development in-house. Obviously, we do a wide range of what those videos and camera-based softwares are doing. And we do a lot of engineering for specific customers to develop something perfect for them, not anything kind of cookie cutter or off the shelf. We got 25 years experience working specifically on these kind of projects with the DoD, and we do a lot of on-site support already for all of our testing and analysis. So we do that also with our field. We do have technical support in the field for our software and commercial, or excuse me, camera-based things as well. So thank you for your time. I'm glad we were able to fit in here at the last minute. Any questions? No, I'm in New Jersey.
Any questions? Any questions? Sorry. Okay. Thank you. I'm glad we were able to, squeeze you in. ODU team, do you want to try and just come hard plug in here or no? It's up to you guys. Do you want to try it? They can't get on internet on that machine. So, all right, I'll take that. Thank you. All right, we're going to try this real quick and see if it works. So it would have to be one of these. And it would be, I think we'd be able to see it in there. Whether we are able to show it. I don't know if I can share it.
Can you bring your own?
Okay, so if are you in there? We're not seeing your screen. Oh, we probably have to change the input. You got it on there, yeah.
Can you send the Zoom link?
You want the Zoom link?
Yeah. Then you
Okay.
can open.